Now in the previous lecture, we have discussed what we should do when the hash table is full. Now here, we will learn pros and cons of collision techniques and which one to choose based on the circumstance. Now in the previous lecture, we have discussed that we have two types of collisions. Now, so you might be interested which one we should use. So to answer this question, let's look at the pros and cons of collision techniques. So the first technique that we have learned is direct chaining. We know that direct chaining is implemented using reference and pointer. So this means that here we don't have a fear of exhausting hash table buckets. So our hash table never gets full, so we can insert as many elements we want. So here, every time when a new element comes, we create a new node and assign it to the existing node. So it never gets full. So this is the biggest advantage of direct chaining. But it does not mean that it is always the best choice, because if we insert more and more elements to it, the linked list becomes very big and it affects the time complexity. It means when we search for an element, the time complexity becomes O(n). But we know that we are using hashing because it performs search operation in O(1) time complexity. So the meaning of hashing gets lost. So in this case, the direct change is not advisable for a particular case. Now let's continue to the next resolution technique, which is open addressing. So one of the advantages of this technique is easy implementation, because here all we have to do is to create an array based on hash function and assign values to it. So here we don't create any new node and assign value to it. All we have to do assign values based on hash values. But in case of open addressing, we have problem of exhausting of hash table. It means when hash table gets full, we have to create a new hash table and assign values to it. And this affects the performance, because if we have n number of elements in the hash table, we have to process all of them one by one to insert to the next hash table. And this will take O(n) time complexity. And this means hashing is not performing as it should be. Now you might be confused that if both cases have pros and cons, and after some time in both cases, time complexities become O(n) time complexity. So which one we should use? So the answer to this question is very simple, which is if the input size is known, then we always use open addressing. Because in this case, we don't need to create a new hash table, which is very time consuming operation. So if we have to insert 10 elements to the hash table, we create an array with the size of 10. And all elements will be located successfully without need an extra cells for this case over here. Now in this case, the biggest problem of open addressing, which is exhausting of hash tables, will never happen. So it will perform very fast for searching, which is O(n) time complexity. Now you might be interested, is there any situation where we can use direct chaining? So if deletion operation is very high, then in this case, we should use direct chaining. Because when we use open addressing in this case, after frequent deletion, many empty cells cause performance leaks for search operation. And this is not space efficient also. So let's look at this very carefully. So let's say we have implemented our hash table using open addressing, and our hash table become full. Now if we delete any string from this hash table, for example, we are deleting ABCD, so this becomes empty over here. Now we know that here we have two strings which return same index. So based on linear probing, we have inserted the last one at the index of 4. Now if we use this hash function for search operation, so we are calling hash function for this string over here, we are getting index of 1. Then we are going to the index of 1. We see that at the index of 1, we haven't found the string. So in case of linear probing, we will continue to the next cell. So in the next cell, we see that it's empty. So our search operation will be stopped over here, because based on linear probing, it should be located at the next cell. So if the next cell is empty, it will return saying that it does not exist in this hash table over here. But actually it exists. Because of this empty cell over here, it does not continue to the next cells in this case. So this causes big problem for searching operation. Now we can solve this by restructuring, but this is also time consuming. So this is the reason why we are not using open addressing in case of frequent deletion. But in case of direct chaining method, delete operation is very simple, so it does not cause us empty cells in the hash table. So we can use direct chaining resolution method for the cases in which we have frequent deletions in our application. Now with this, we have completed this lecture. Now in the next lecture, let's look some practical use of hashing. So see you in the next lecture.